The world's most famous passenger jet may finally be reaching the end of its journey. This is the Boeing 737, the single aircraft family that has carried more than 17 billion passengers since its debut in 1968. It has been the backbone of airlines like Southwest, Ryanair, and United, racking up over 11,000 orders and defining short-haul travel for more than 5 decades. But after multiple crashes involving the 737 MAX, billions of dollars in settlements, and a reputation battered by delays and safety concerns, Boeing knows its legendary jet cannot fly forever. Executives are under pressure to design a next-generation aircraft by the mid-2030s, one that can compete with Airbus's A320neo and future hydrogen or hybrid designs. The company faces a massive gamble: retire its most successful jet and risk falling behind, or reinvent it for an aviation market demanding cleaner, faster, and more efficient planes. To understand how legendary this aircraft is, we need to go back to the very beginning. The story of the Boeing 737 begins in the early 1960s, when Boeing decided to build a short to medium range jetliner to compete with the likes of the BAC-111 and Douglas DC-9. Engineers like Joe Sutter and Jack Steiner laid down initial specifications around November 1964. The goal? A small twin-engine aircraft capable of carrying roughly 60 to 85 passengers, operating from shorter runways, and offering the comfort of jets to regional routes. The first variant, the 737-100, was rolled out on January 17, 1967, and flew for the first time on April 9th of that same year. Its certification by the Federal Aviation Administration came in December 1967, and Lufthansa became the first non-American airline to take delivery in February 1968. Only 30 units of the -100 model were ever produced. Boeing quickly followed with the -200 variant, a stretched version offering greater passenger capacity, which entered service with more airlines. Over time, the family evolved. The Classic series, -300, -400, -500 arrived in the 1980s, introducing high bypass turbofan engines, CFM56, improved aerodynamics, and larger fuselages. It enabled longer routes, better fuel efficiency, and more seats. Then came the next generation, often called 737 NG. First flown in 1997, the NG introduced redesigned wings, higher maximum takeoff weights, extended range, and more modern avionics and interiors. The -800 became the most popular of the NG series. Airlines loved its balance of efficiency and capacity. Finally, the 737 MAX family was introduced in 2017. The MAX variants included new, more efficient LEAP-1B engines and improved fuel consumption. As of mid-2025, there remain thousands of outstanding MAX orders globally, and airlines are still awaiting certain MAX variant certifications, especially the MAX 10 and MAX 7. In terms of numbers, the 737 has been extraordinarily successful. To date, more than 17,000 Boeing 737s have been ordered across the original, Classic, NG, and MAX families. Of those, the NG alone saw over 7,000 units delivered. In many years, the 737 was the best-selling commercial jet in terms of orders. This was profound to say the least. Its specifications reflect both simplicity and adaptability. The early -100 carried roughly 60 to 80 passengers. The NG-800 seats approximately 150 to 200. Range has increased over generations, from about 1,000 miles in early variants to over 3,000 miles in newer models under favorable load conditions. Wing designs, fuselage structure, and cockpit instrumentation were gradually modernized across versions. Over decades, airlines like Southwest, Ryanair, United, and many others built large fleets of 737s, making maintenance, pilot training, and parts supply more efficient due to commonality across variants. That consistency has been a core part of the 737's success. And now, with the aircraft aging and regulatory pressures growing, Boeing is quietly planning what might follow the 737. A next-generation model built for the mid-2030s, aiming to replace its most famous jet while matching modern demands. Curious about what comes after one of the greatest success stories in aviation? Stay tuned, because what follows is not just about replacing an aircraft, it is about understanding Boeing's high-stakes gamble, the competitive race with Airbus, and the technologies that could define how billions of passengers will fly in the decades ahead. The 737 has carried passengers through oil crises, deregulation, and the rise of low-cost carriers, but its dominance is facing limits. The next jet is expected to do more than inherit a legacy. It must set a new benchmark for range, fuel savings, and environmental performance in the 21st century. Industry insiders believe it could feature radical new engine placements, composite wings, and even early hybrid systems. Yet, behind the promise lies turbulence. Certification battles, production delays, supply chain strain, and enormous financial pressure on Boeing's balance sheet. Regulators, rival manufacturers, and even government agencies are watching closely, knowing that if Boeing stumbles again, the future of American leadership in aviation could be at risk. But will the company succeed in shaping a worthy successor, or will history repeat itself? That question remains wide open. The 737 changed the world once, but its successor must transform aviation itself. But first, let us look into the failures that ruined the 737. Stay tuned. The Boeing 737's reputation cracked in dramatic fashion with the two tragedies that changed aviation forever: the Lion Air crash in October 2018 and the Ethiopian Airlines crash in March 2019. Those two accidents, which together killed 346 people, exposed a fatal interaction between a new flight control feature and sensors, and led to the worldwide grounding of the 737 MAX fleet while regulators demanded fixes. What you're about to read will make the stakes painfully clear. Investigators trace the problem to the maneuvering characteristics augmentation system and to wider issues in certification and documentation. Boeing and regulators were criticized for how the MAX was approved, and the company eventually reached a multi-billion-dollar settlement with the U.S. Department of Justice and victims' families for failures tied to the crashes. That chapter left scars on Boeing's technical credibility and on global trust in U.S. aircraft certification. And wait until you hear this. Those settlements and penalties were only the start of a long accountability process. The years that followed were meant to be corrective: software updates, revised pilot training, and new oversight. But new incidents kept surfacing. In January 2024, a mid-air door plug panel detached from a 737 MAX 9 shortly after takeoff, prompting immediate groundings, aggressive FAA oversight, and renewed scrutiny of production quality. By June 2025, the National Transportation Safety Board publicly criticized Boeing for inadequate training, guidance, and oversight that contributed to such safety lapses. What you're about to hear will shock many who assumed the MAX era was fully behind us. Safety problems have not been limited to MAX software. 2020 to 2025 also saw serious in-service incidents on non-MAX 737s, including an engine fire that forced an emergency evacuation in March 2025, and multiple reports of structural or component failures reported worldwide. Each event renewed pressure on airlines, regulators, and Boeing to show that the family is safe to fly and to prove that fixes are durable, not temporary patches. And trust me, the repeated headlines left passengers and executives asking uncomfortable questions. In Washington and in foreign capitals, regulators tightened requirements. The FAA imposed enhanced in-person oversight at Boeing's Renton plant and placed caps on production until quality could be assured. Congressional hearings, NTSB reports, and DOJ inquiries turned routine certification work into a political and legal minefield. Boeing's challenge is not only technical, it must rebuild the institutional confidence of regulators, airlines, and passengers. What you're about to hear next will explain why rebuilding is the single most important task for the company's future. The failure here is about the factory floor, and what went wrong there is just as consequential. In the push to meet delivery targets after the MAX recertification, Boeing's Renton production lines and key suppliers showed systemic quality control lapses, improperly installed parts, gaps in documentation, and pressure on workers to sign off on work they believed incomplete. The FAA's audits documented hundreds of quality system violations, and regulators moved from advisory to enforcement. What you're about to hear will make it obvious why production problems matter as much as design flaws. Manufacturing failures have tangible effects: missing fasteners, improperly torqued bolts, and incorrectly installed panels have been linked to in-service incidents. In one high-profile case, regulators concluded Boeing presented aircraft as airworthy when quality records did not support that claim. The result was a production cap on 737 MAX deliveries, more intrusive inspections, and a wave of retrofits on aircraft already in airline service. Those fixes cost time and money, and the cumulative effect was a severe hit to Boeing's supply chain relationships and workforce morale. And wait until you hear this. Suppliers such as Spirit Aerosystems were repeatedly cited for lapses as well, showing the problem was not limited to Boeing's own shops. Leadership and governance failures deepened the crisis. Senior executives who had steered Boeing through rapid expansion were replaced or shuffled after critics said management prioritized production speed over quality. Internal whistleblower reports and external investigations made clear that incentives and performance targets had at times pushed employees toward shortcuts. That culture problem transformed technical defects into corporate liabilities, and the company's public statements shifted from defensive to apologetic as external investigations mounted. Financial consequences followed quickly. Between settlements related to the MAX crashes, the costs of retrofits and inspections, and the impact of slow deliveries, Boeing's balance sheet took a severe hit. Regulators even threatened fines. The FAA proposed a $3.1 million fine in September 2025 for repeated safety violations, and the Department of Justice has been actively investigating whether earlier prosecutorial agreements were violated. For an aerospace giant that relies on both commercial and government business, these financial blows raise questions about how fast Boeing can invest in a credible successor to the 737. And trust me, money talks. And right now, it is shouting. Finally, output constraints and reputational damage gave Airbus and other competitors openings to press market advantage. Airlines facing uncertainty about deliveries and reliability must balance fleet commonality against risk, and that calculus now includes whether a 70-year-old production model can stay dominant in a world demanding cleaner, safer aircraft. The production crisis is not just a manufacturing story. It is a strategic problem that shapes Boeing's ability to lead the next generation of single-aisle jets. Boeing has been quietly working on what many in the industry refer to as the new midsize airplane, or NMA. Essentially a clean sheet jet aimed to sit between the 737 and the 787 in size. Under code names like 797 in media speculation, Boeing has explored designs with composite materials, advanced aerodynamic wings, and engine technology beyond what the current 737 MAX uses. What you're about to hear will show how radical the leap could be. The proposed aircraft is expected to offer seating for roughly 200 to 250 passengers in its base version, with variants stretching both longer and shorter depending on market demand. Range targets have been muted in public comments but are believed to fall between 5,000 nautical miles and 6,000 nautical miles for longer haul variants, far beyond what the 737 MAX currently achieves. In propulsion, Boeing is evaluating options including high bypass ratio turbofans with improved bypass airflow, possibly exploring hybrid propulsion or hydrogen readiness down the line, even if the initial airplane is not hydrogen-powered. Engines will need higher efficiency per seat and lower fuel burn by at least 20 to 30% over current models. Composite wings and lighter materials are also central to design, aimed at reducing weight and enhancing aerodynamic performance. Modern avionics, digital cockpits, fly-by-wire control surfaces, and new flight displays are part of the specification mix. Airport compatibility is a major constraint. The jet must operate from existing gates, runways, and taxiways built for 737s. That means the new aircraft will likely retain narrow body width constraints, similar cabin cross sections, and possibly modified landing gear for clearance. This balancing act between innovation and infrastructure compatibility is a key technical hurdle. Boeing has signaled that they are pushing back on earlier plans to stretch the 737 MAX further and instead focus on this new clean sheet design to escape the limitations of legacy fuselage and engine placement. Under internal projects of sometimes described as Yellowstone Project, the company has been studying what it actually takes to deliver such an aircraft by the mid-30s. But here's the catch. Technical feasibility does not guarantee timely delivery. Regulation, certification, supply of composite materials, and development costs remain huge unknowns. In sum, Boeing's next jet promises to be more than a 737 with tweaks. It may be the transformation aviation needs. But before airlines and travelers see it in the skies, Boeing must prove it can scale new engines, modernize factories, and win regulatory approval without repeating past mistakes. If Boeing's next-generation model succeeds, it must outperform the 737 on multiple fronts: fuel efficiency, emissions, safety, operational cost, and passenger comfort. Already, engines with higher bypass, lighter materials like composites, and cleaner aerodynamics offer paths to reduce fuel burn by an estimated 20 to 30% per seat. Airlines will likely demand lower maintenance costs and better dispatch reliability, areas where the 737 has recently stumbled due to quality issues. One major advantage the new jet can have: reduced certification risk. With FAA and international regulators scrutinizing manufacturing and oversight more tightly post-MAX and post the door plug incidents, Boeing has the chance to embed stronger safety culture from the start, not retrofits. It can avoid technical debt carried by legacy designs, skipping over weak spots in structure or system integration. And yes, what you're about to hear might give you hope that Boeing can learn from its mistakes. Yet, obstacles loom large. First, development costs could run into tens of billions of dollars, risking overruns. Supply chains for composite wings, advanced engines, and other new systems are already strained globally. Second, airlines may resist radical change if fleet commonality and pilot training costs grow too much. Third, regulatory approval will be tougher. Agencies demand not just incremental improvements, but proofs of compliance with safety after multiple high-profile incidents in 2020 to 2025. Engine fires, door plug failures, structural defects. Fourth, Boeing's reputation has taken blows. Assurances from leadership will be met with public skepticism. Another key obstacle is competition. Airbus and OEMs in Asia are similarly investing in fuel-efficient narrow-body and successor designs. The market for new single-aisle jets is crowded, and Boeing must not only build a better aircraft, but get it certified and delivered ahead of rivals to reclaim market leadership. If Boeing can navigate these engineering, regulatory, financial, and competitive hazards, the successor could well set new standards for safety, sustainability, and cost. If not, it risks being remembered as the plane that tried to replace the 737, but never quite broke free of its burdens. For Boeing, the new midsize jet is more than just an airplane. It is a test of survival. After decades of relying on the 737, the company knows it cannot afford another stumble. The new design represents an escape from legacy constraints, a chance to reset its reputation, and a wager that airlines will pay for innovation. But delays, costs, and relentless scrutiny mean the aircraft is not simply a product. It is Boeing's credibility on the line. As regulators, passengers, and competitors watch closely, the jet has become the ultimate gamble. This isn't just a replacement for the 737. It is a question of whether Boeing can still lead the skies at all. Some airplanes define travel. Others become warnings etched in aviation history. The 737's legacy is unmatched, but its successor may decide whether Boeing regains trust or cedes the future to rivals. That's why we tell these stories, not only about wings and engines, but about ambition, mistakes, and redemption. If you want more deep dives into aviation's biggest turning points, make sure to subscribe, hit the like button, and tap the notification bell. We'll explore the icons, the failures, and the bold experiments that changed how the world flies. And if there's a plane you want us to uncover next, drop it in the comments. Your idea might just be our next flight.